So I think it's now 13:50. So given the dial warnings that I had in the emails about overrunning, I better start on time. Hi everyone, my name's Winston Bond. I'm here to talk about the new addition this year to the OWASP top 10 mobile vulnerabilities list. So I'm actually late stand-in. So the pre-conference publicity was talking about a gentleman called Jonathan Carter, who was going to be doing this talk, but unfortunately he can't make it over from California, so I'm doing it instead. So that's a slightly good news, bad news story. The bad news is that I'm much less aware of the OWASP process and what went into the development of the top 10, and to possibly some of the if there's any historical stuff or sensitivities or anything, I'm much less conscious of that. The good news is I'm pretty well on top of the subject. I have been doing it I've been working in this kind of arena for about 6 years, so I believe I know what I'm talking about. But go easy on me with the questions, okay? So, so that's the introduction. What's our talk about, or the talk? It's mainly just to try and go over what this addition to the top 10 is. It's what does it mean? Why does it matter? To some degree, what can you do about it? So I think the name of the vulnerability is lack of binary protections. Basically, it boils down to someone can take your mobile app and poke around with it or change it. So unless you've done something about that, you've got a bit of a problem on your hands in some circumstances. Oh, I'm going to pause. I found this when I was coming into some of these talks. Everyone bunches up at that end, so it's really hard to find a seat halfway through. So just come on past. So this is just a separating slide. There's not a lot to say. So we're just going to. I'm going to talk in a little bit more detail about what this addition to the top 10 is. Or what the top 10 is. So the OWASP top 10 was updated in January with some different vulnerabilities, and I guess given a year of experience since the first OWASP mobile top 10 was announced, there were some ups and some downs. In the hit parade of what's viewed as important, or the relative merit or relative importance of these things, and was added to this extra category at the end was added, lack of binary protection. So some of these, I'm not going to go through them all in great detail, mostly because I don't know them in great detail. So the top of the list, obviously, insecure data storage. If your data on your mobile phone is insecure, just like on any computing platform, it's easy to get at. Weak server-side controls. Some of these are kind of, I read through these, and they're very much the same as you'd have in a web application. A sort of thin client web app. You're worried about client-side injection and people typing the right cryptic runes into a text box to do a SQL query on your database. So that's still there, and if you've written your mobile app just like a web app, that's going to be there. But really, they have the ultimate power on a mobile app. We're back in the thick client world again, where the client application does stuff. It doesn't just send key presses through to your web server. So they have the ability to make that mobile app send off its own SQL query if you've got that vulnerability. If they reverse engineer it, figure out how it works, change it, they can do what they like. I guess poor authentication. If your login process doesn't work, it's still not going to work in a mobile app. And in fact, in some ways, it's worse because you want it to be simpler in a mobile app. Typing in your 16-digit ID number and seven digits out of 54 for your password and all the rest of it. That's very hard to do in a mobile app. Slightly defeats the purpose. So anyway, they're all important vulnerabilities. Some kind of coming over from the web world, and some like this one back in the issues you have to deal with when the client has a brain or is a little bit more than just a display. So what is it all about? So top of the list, basically, your mobile app is out there. It's on someone's phone. Probably half the people in this room are pen testers and know how to take it off your phone without an awful lot of difficulty. Even if you're not a pen tester, it's not that hard. So you can get it off. You can fiddle around with it. Have a look at what it's doing. It's not difficult, and if it's not even expensive. If you're for Android apps, for example, all the tools to reverse engineer it are free. And then they can, your person who's doing that can then change that binary potentially, put it back together, load it back on the phone, distribute it through a different place, not Play Store, through a different app store, and it can do whatever it wants to do on somebody's phone. And the damage that causes, who knows really? It can be all kinds of different things. If it's your mobile, if you're a big company, it's your mobile app that gets cracked in some way, that's doing something weird to people's phones. In the end, the blame's going to end up with you, even if it wasn't your fault. Or it can be more directly damaging if someone figures out how to break the login system for your banking app and starts to steal money off people. It's real money kicking around. If you have some super secret algorithm running on the mobile phone, and someone can reverse engineer how that works, again, that might be bad. Or that probably is bad. Is there much chance of the super secret algorithm running on the mobile phone rather than locked in the data center? I don't know. It depends. Depends on who you are. There are circumstances where it might be running on the mobile phone. If you've got a phone app, I don't know, figuring out how you drive and working out your insurance premium, that's going to have to do a lot of stuff on the phone. It's not going to be telling a server, or it can't tell the server, every 3 seconds, what you're doing with the accelerator. So all of that stuff is there. It's open to being reverse engineered and fiddled around with, if necessary, by somebody. So that's the vulnerability. I'm running ahead of myself, aren't I? So, what do these kind of attacks result in? So, I guess one other thing that somebody might be able to do is if you have security controls that you've embedded into the thing to stop certain kinds of attack, they might be able to dodge them. So an obvious one on that is jailbreak detection. If you go down a route of deciding that your app is only going to run on non-jailbroken, non-rooted devices, then you are going to have to sort of toughen that up a little bit, because people are going to try to dodge it. They're going to try and cut it off. You're going to have, you're into a bit of a fight with the people who want to run it on a jailbroken device. Whether it's right or wrong doesn't really matter. There are circumstances where you probably would want to stop that, because if you're running on the jailbroken rooted device, it's kind of starting to open up the security model. People want the freedom to have the free copy of Angry Birds or whatever, but on the other hand, they'll be really cross when their bank account gets emptied. So that, you have to stop people compromising the things you've put in there. You can have the sensitive information in there potentially. Whether there should or shouldn't be that sensitive information in that app is probably open to argument, and there's probably lots and lots of best practices that say don't put sensitive things in apps. Sometimes you've just got to. You can't avoid it. Or sometimes they're just there and nobody's done the right things to eliminate those vulnerabilities in advance. And then back to the same point, someone can, if someone is able to reverse engineer that app and take out some of the logic. If your mobile app is doing the stuff that stops people launching SQL injection attacks, it's probably a bad idea anyway, but if that's where you've put that, that logic, someone might bypass it. Oh, let's continue with things. Oh, I guess other things. Someone uses your app to, or repackages your app with something else in there. That's probably, that is a bad thing. We've talked about, reverse engineering on some applications being a problem. And I guess also, the reverse engineering step is a step in the road towards understanding vulnerabilities. So if your mobile app is controlling what your server is doing, then understanding what the mobile app does is a good step towards understanding how to drive the server and make it do what you want it to do. Am I just repeating myself here? I am, aren't I? So, the last one, IP theft. We talked about that. Piracy, getting a free copy, you're cutting off the licensing. That's, in mobile apps, that's not generally huge. Well, it's there, it exists. You go to the Cydia store and you can get yourself whatever you like, really. But does anybody really care enough to do much about it? When you're talking about a 99p game, probably not really. But if you end up with a mobile app that has a significant price tag, then if you've got, I don't know, a sat-nav application for £100 rather than one, then all of a sudden stopping somebody pirating that becomes a bit more interesting. How prevalent are these attacks? I think there was an HP research effort that a gentleman outside was telling me earlier on was, they looked at 1,000 mobile apps on a well-known application distribution platform for mobile apps, and discovered that most of them are vulnerable to an attack of some kind, and most of them don't do anything at all to stop you, reverse engineering them or modifying them. So what those vulnerabilities are, I guess everyone is going to have its own vulnerability in their own different ways. Whether they matter or not, again, that depends on who it is and what it is. If it's the One Direction application, you're probably not that bothered, really. Pick the boy band of your choice. I'm not trying to promote anyone in particular. But again, if it is a movie player application for DRM protected movies, that certainly the people who sell the movies to you will be quite bothered about that, and they will want to make sure that they are as tough as they can be in protecting them. So again, what do people want to do when they're attacking these things? Same stuff we've already talked about. Bypassing the security controls that you've put in there. So jailbreak detection, stuff to keep the DRM from being bypassed or finding the keys inside it. Potentially adding, somebody adds their own code, redistributes it, repackages your app as their own. So I guess you can, where would you want to do that? And I guess if you wanted to produce your own Flappy Birds clone in the easiest possible way, you'd take the original one and repackage it. And then, stealing information about users. This is a sort of classic web vulnerability and something that people, are concerned about. If you've got a modified version of an app that's then sending off user credentials off to your own private server somewhere, then that's not, you as a big company whose app is being attacked in that way, that's going to be a bit of a problem for you in the long term. I can't remember, I wish I could remember the details, but I read a report a couple of months ago about, a mobile app being attacked through one of the kind of vulnerabilities we're talking about here, to redirect, to send off login credentials off to another server. For no apparent purpose, but it's a bad thing, isn't it, if your login credentials are getting sent somewhere. So this is trying to kind of show different areas of risk that you have, business risk. Is someone going to steal your money? Operational risk, is someone going to break your system? Technical risk, I guess that boils down to, is someone going to work out how your software works and steal it? And you can kind of separate those into two parts. There's a confidentiality side to it and an integrity side to it, which again, to boil it down even simpler terms, one is, the confidentiality is one is understanding how your code works, and the other one is changing it. Which are two sides of the same coin. It's kind of hard to change it until you understand how it works. Ask anyone who does maintenance on big company software. But it's, so the first step, I'm going to talk about these in reverse order. To code modification, what are the risks, what people might be doing? So repackaging it, changing it, redistributing it. Method swizzling. Anyone heard of method swizzling? Excellent. It's good. Some, at least. So method swizzling is a wonderful thing. It's a lovely feature of the Objective-C language where you can redirect what things do at runtime without changing the code. So as a developer, it's a great thing. If you're and it's one of the sorts of thing that people like about Objective-C as a programming language. From a security point of view, it's absolute nightmare, because someone can take your lovely jailbreak detection routine and they can say, actually, I don't need that one anymore. I'm going to use my own that does nothing at all. And you can do that at runtime without changing the code for the software. You do have to be on a jailbroken phone to do it, though. Security control bypass, so that's, if you've got your own stuff in there to, check your environment, check that no one's changed anything, make sure it's all legitimate, people are going to try and get around that. I guess that this is the same, jailbreak root detection disabling is in the same category, where people, go for it. That's all right. So yeah, people will also, will try to, turn off your jailbreak detection because it's their right. Presentation layer, so making your UI show different things. Key replacement, or I guess the first step against someone finding your key is to use an algorithm where even if they find the key, it doesn't matter. The trouble then, so you're into public key. The vulnerability there is, well, maybe they'll just find your key and put one where they already know the other half. So they're not going to work out a private key from a public key, fair enough. But if they already know the other side, they can just replace the one that's buried in your code, which then lets them do a man in the middle or something like that, again, on you. Yeah, go for it. So there are, there's a number of risks. I'm sure there's others. It's basically if you can modify the app, you can make the app do anything you want. And what anything you want is up to you, and whether it matters or not, again, depends on who you are. So this is the swizzling example, where here's a bit of Objective-C code that basically says there's a method. I must remember the word. Sorry, I'm an old-fashioned guy. I call them functions, but there's a method which it takes two parameters. One is your username and one is your password, and says whether you can log in or not. It's probably not a very wise piece of design anyway, but it's an example. So somebody could come along and just replace that whole thing and say, yeah, we're always going to be happy. As far as the app's concerned, we've always logged in. The world's good. The standard runtime on the phone isn't going to do anything to detect that or stop that. It's designed that way. That's what it's for. The next one, similarly, here, this is, again, another Objective-C iOS example where someone, goes through and finds your function that says, are we jailbroken? And, we'll override it. So, first off, they probably just swizzle the whole thing out of the way so that it's always going to be happy. If they don't do that, they could just make it return true all the time. Sorry, true, false, false. You'd want false, wouldn't you? So it's always going to be, it's always going to say happy. Although to do that, they'd then have to be, that's changing the code. They'd have to re-sign it to make it work very far. In any case, this string here is going to be blindingly obvious in the code. So they'll be able to find that in the code, understand how your simple jailbreaking detection works, and then know that if they rename cydia.app to something else, then you're never going to find it. So there's this piece of code, which this is source code, but you could get that back off the binary on the phone fairly simply. Even if you don't go and buy a decompiler, you could get the assembler code and you'd understand that really quite quickly. The other side of this, the reverse engineering part. So really, this ought to come first, because this is the first thing you'd have to do, is get your app, figure out what it's doing. So what are the risks? So there's the method signatures. So again, actually all of the, so either Java for Android or Objective-C on iOS, all the method names and the parameter names and the, just what it looks like, or what your well-engineered software design says about itself, is all exposed in the binary. So you can just read that. Go ahead, just go to the other side. It's probably the simplest. Don't worry, it's fine.
It's not a movie.
Yeah. So yeah, all of your, all the things that as a well-trained software engineer you do by giving things nice, friendly names, that's all there to help someone understand your binary, unless you do something about it. API monitoring, so people will be able to figure out what you're doing by looking at what system APIs you're calling and monitoring those at runtime potentially, or changing, redirecting them at runtime if necessary. Exposed data, so again, the data and the strings and the crypto keys and all the rest of it that you have embedded in your binary are there for anyone to find and have a look at and do what they want with. Decompilation, trivially simple on Java, .NET, a bit harder on Objective-C and C code, but still doable. And you can certainly analyze it to work out what's going on. I guess, application decryption, that's I really should have put that at the top. Yeah, so that's the first thing you have to do. Application packages on iOS are encrypted. So if you just take the thing that iTunes has stored on your disk and try and have a look at it with a disassembler, you won't mean anything because it's encrypted. But it's fairly straightforward to get it decrypted and get it back off the device again. So that is the first step. Just because the phone vendor encrypts the binary for you doesn't mean you're safe for very long. It's really, there are I guess that's the thing with any standard technique. You know, every single app is encrypted in a similar way. So there's a standard way to unpack that. Just like in, I guess, the web world, you know, everyone uses the same 4 or 5 browsers, and it used to be everyone used the same one browser, pretty much. So, you know, once you'd worked out how to attack that one, you know, it's toast. The same with encrypted binaries. You know, it has to run on the processor in the end, so there has to be a way to decrypt it. So, you know, we mentioned this. You know, if you've got an embedded cryptography key in your application, it's probably something you don't really want people to read. You know, and you can say it's a dumb thing to do, and it probably breaks 1,000 guidelines of the thing to do. But sometimes you can't avoid it. You know, if it has to work online, offline, it can't get something from somewhere else. You don't want it to necessarily be asking the user for a piece of input, but you still want to keep some data, you know, avoided, you know, hidden from casual, you know, someone kicking the tires, just having a look around. It might be hard to avoid having some kind of key in there. So, you know, you want to hide those, or you want to stop someone reverse engineering those. Yeah, oh no, it's not on this, but, you know, a similar an example. You know, I was looking at a binary at an application that I use on my phone, and it's not a security critical application, but I was having a look around in this just out of curiosity, frankly. Probably shouldn't have done, but there we go. And you have a look through this code. It's done nothing to hide anything in it, and they've got the, you know, fairly standard, as people do. They put the test server login on there, you know, embedded in the code. That's great. And then you look down the list and you find that the developer's personal login is in there as well. You know, and then it turns out this guy's a security consultant as well. You know what? That's really not a very clever idea. You know, if I was that bothered, you know, I could log in as you. So, you know, those sorts of things people do, and you want to be able, you know, I guess, you know, by design you might have to put a crypto key in. There might be stuff that's just left in there through probably laziness is probably the best description for it. You should probably kind of do something to mitigate someone, you know, finding that, you know, so easily and making use of it. Debugger detection. So, you know, anyone trying to reverse engineer your app is going to try and attack it, or particularly if they're going to try and change it, they're going to try and attach a debugger to it. It's very hard, actually, to stop somebody ever attaching a debugger to something. It's really, really hard. But you should at least try and make life a little bit difficult for them by doing some basic checks for debuggers at the standard entry points and some places in the UI. So this is so we talked about, you know, some ways people are going to attack your code based on, you know, reverse engineering it or changing it. I think that this now talks about, you know, some other things or practical things you can do. So, you know, I guess it's fairly straightforward. You know, you know, if you do good things, you know, implement or use good algorithms. So if you're going to do jailbreak and root detection, you're in for a bit of a battle, but, you know, you know, you can choose algorithms which will work. You know, do some checksumming on your code. So that if, you know, the signature checks that built into the OSs do some checksums for you. Basically, when it loads, it has a look and says, has anyone changed this? Well, if they've changed it, the signature is going to fail. So that's a very basic check at load time, but it only happens once. You know, I'd suggest, or it's a good idea to do a bit, you know, inside your own code as well. I believe certificate pinning, basically that means, you know, making your crypto keys only work on this device. So that's about cryptography design, about you know, and I guess well, it is basically about cryptography design and stopping people understanding how that works, if you can. Debugger detection, again, good thing to do. And all of this stuff needs to be protected from reverse engineering or code changes to the degree you can, which is to a very large degree. Yeah. So yeah, this is a catch-all. This is your mobile app must be. In truth, it's probably if you care, your mobile app must be able to do this. Again, there's lots of mobile apps out there for different things, doing different doing different things in different ways for different people. And for a lot of them, nobody's that bothered probably. But if it's starting to if it gives a way into some user database, or it's storing stuff there that's user data, or if it's controlling money or something that's worth money, then you really need to start thinking about securing it. So you need to stop someone reverse engineering it for a start, because that's just the very first step they're going to take if they want to do anything to it. Then you need to look at it at runtime, not just when the OS loads it, or look at your code at runtime, and potentially some of the other files around it as well. I can never remember the alphabet soup of p lists and whatever else there is. All the different properties files around the app that can control what they can do, and it needs to react appropriately. So you need to make some decisions about what you're going to do if you find out that someone is trying to attach a debugger to it. What do you want? Do you want to log them out? Do you want to, just give them a nice friendly warning on the screen? Do you want the program to crash? Do you want to send the heavies round? It's up to you. What do you want to do? So yeah, there's some choices you as a developer have to make. Defense in depth. Whatever you do in your code, it's only software in the end. So if you have a checksum in there that's checking whether it's whether someone's changed the code, it boils down to a branch in the end. Something's going to say, is it right or is it wrong? So once they've found that, they can remove it. So really, you need defense in depth. You need lots of different things, all looking at each other, and all looking after each other, and don't rely on one single control to stop someone attacking your app. I need to move off this slide because I'll get in trouble because it's just slightly close to what Arcsen's product does.
Doesn't stop every other presentation.
Okay, that's fine. That's fine. I'm sorry. I read the presenter agreement, and
Right.
yeah, and I know that my children will be harmed if I say the company's name too often. So anyway, yeah. So conclusions. Binary attacks. They are quite common. They're quite easy to mount. And the majority of mobile apps, I'd say that the large majority don't do an awful lot about it. Now the lack of binary protection is in the top 10. I hope it's going to move up the hit parade in 2015. As people realize it's a major threat. To stop it, as a developer, you'll have to do something about it, because the things built into the platform don't do it for you. They do some things, they're very good at some things, but this particular attack vector, they aren't going to do anything about. This part I'm skating on very thin ice because I don't really know what I'm talking about. So other mobile projects. So there's a link there for the OWASP top 10 that goes through that list that we had at the start, talking in detail about each vulnerability on the list. I think and I guess this is the more details on this particular subject on the OS website. So that is the end of my presentation. I think I'm running a little bit early. But, so has anyone got any questions? Make them easy ones, please.
Thank you. So you did mention if the app does anything sensitive,
Yeah.
and you need to start thinking about how to secure it,
Yeah.
which I couldn't agree with you more.
Yeah.
Then all the examples you provided
Yeah.
on why you should think about implementing this control mainly rotate about client-side validation or hard-coding secret, which, as you will agree, is probably you should avoid doing that at the first place.
Sure.
So my question to you will be, it seems to me this control that somehow ended up in that mobile top 10 risk is about security for obscurity. And it's not necessarily a good thing because it hides the vulnerability that you have in your app, and you should remediate those vulnerabilities instead of trying to hide them. Especially that, sorry, just the last bit, especially that technically you're just making it harder because technically it will still be possible, since this is client-side code, to actually be able to see the code.
Yeah, I can see what you're saying. That in an ideal world, you wouldn't need this. But there's a few things that kind of make it a less than ideal world. That, you know, one, you know, that there is the one that, you know, there's been lists and guidelines and scanning tools and all sorts of things that will tell you how to write code for a long time, but problems still exist. You know, so, you know, that's the kind of reality, I suppose. Then you're also dealing with, you know, you've got mobile developers who have to get their app out in, you know, 3 weeks, or you know, 3 weeks is an exaggeration, but a few months to get the project, you know, going, and their focus is on, you know, just making the UI work and joining everything together, and they might be sloppy, you know, almost certainly will be. And then there's sometimes it is just necessary to do things, or you have something that you just, you know, however good your design is, you need to stop people understanding what's going on there, because, well, you know, I don't know why. Well, sorry, I need to think of, you know, to think of a good example. It's hard to think of a great example of, you know, where somebody, you know, just in the end there is going to be a vulnerability there. That DRM player is a great one, you know. So in a DRM player, there's some cryptography happens, and it just turns out that the private key has to be in the player. So, you know, you've got to hide the private key and stop someone understanding that, stop somebody then, you know, playing around with the app, finding the symmetric key that's used to encrypt the video, so they can dump it. And, you know, in a perfect world, all of that stuff would be handled in hardware, you know, and there would almost be no software involvement in the process. It would just get taken care of for you. But that's not how things are. You know, the mobile platforms are designed how they are. The user APIs are what they are, and they don't allow you to just take all that stuff away and do it by magic. So I agree with you that in a perfect world, you wouldn't need any of this stuff. I think in the actual world, there are, you know, imperfections around that mean that you have to. Okay?
Thank you.
Okay. I'll repeat the question. That's okay. Yeah.
Okay, thank you. What's the difference? It's more a provoking question, excuse me. A little bit under the hood, it seems to me like you're doing license protection, or part of it is license protection, or license violation protection. So what's the difference to standard desktop or server applications? And
what's the difference between this and desktop, standard desktops? Not a great deal, honestly. You know, a mobile platform binary in the end is a lot like a desktop platform binary. I think the difference comes in where it's used and how it's used. A mobile app, for all the noise that people make about, not trusting mobile apps, you really do, you spend a lot more time with your mobile and trust your mobile phone a lot more than pretty much any other piece of technology. It's there when you go to bed, it's there when you wake up, it's there with you all day. You do your banking on it, you do, all sorts, you keep in touch with your friends on it. It's your constant companion. So people are growing into the habit of, you type a few digits into it, and it identifies you as you, and you're into your bank account. Whereas you don't have that in a Windows PC, for example.
Well, of course.
Picking at a brand.
Well, of course, you have in the Windows world, you also have some kind of sites which offer downloads of Microsoft whatever. And they contain malware because people just whole operating systems. Isn't that kind of reinventing the wheel? I mean, there wasn't there on the desktop. It seems to me, I'm not an expert there. It seems there isn't really a solution. I don't know. I can tell. Maybe you can go this far, but you never reach. It's an arms race.
Sure. I mean, to dance that very thin edge, that I have to dance on at an OWASP presentation, you can do all of these techniques on desktop platforms as well. And if you have an application where you have this kind of sensitive stuff, or you want somebody to stop somebody cutting off your license protection, it can be done on desktop platforms just as much as on mobile. But the focus here is on the mobile vulnerabilities and the mobile top 10.
Thanks.
You get some exercise.
Yeah, you can repeat the question. I'm doing some exercise today. That's good. Now you don't want to ask anything, right?
I forgot about that.
Excellent. Phew.
Do you see, as a partial solution for cryptography to use TPM? Are you aware of the TPM module?
Yeah.
Do you think that is going to improve, or because then technically you can put your keys on a silicon chip, then it will be almost impossible for another app to side channel spoofing on? Yeah. Do you think that's going to solve most of the problems, or?
Technically, it's a great idea.
Okay.
Love it to bits.
Okay.
But TPMs have been in PCs for 10 years.
Okay.
How many of them actually get used? And I don't know anything about roadmaps and so on. But on an iPhone or an iOS device, you can't get to the. I bet there's hardware cryptography in there, but you can't get to it in a user app. Android, I think, has started to let you, as of KitKat, do some things down in the hardware layer. There are all kinds of practical business issues around it as well, where you have to have multiple partners playing together to give you access to that hardware to let you put something on there. It just it's never really taken off. So whilst in principle it's a great idea, so far it's never really gone anywhere. And if you were starting today, you'd still have to assume that your mobile app doesn't have access to that, because it probably won't on most of the devices it bumps into. Give it a few years and you might be able to assume it's there. But I'm not sure that clock has started ticking yet, because it's only on it's only on the very latest Android devices that you can get to hardware crypto right now.
Yeah, there is one on Windows Mobile.
Okay,
Telling you, do we have some proof of concept for even authentication? So,
right.
But yeah, I can't say when it will be available. But the idea is to give an API for developers so that they can keep the keys on that one.
I think it's a great idea, and if Windows Mobile is going in that direction, I think that's that's fantastic. You just need to drag everyone else along as well. Again,
Okay.
Thanks.
Cool.
Anything else? I guess we're done. Thank you very much for listening, everybody.